Hello, Mrs. Finley here. We're going to look at probability today. So first of all, we need to know what probability is. So some of you have maybe done it before or heard of it. Some of you, it might be completely new. Well, probability is how likely things are to happen. So if we think about chance and likelihood, that's really the topic of probability. Okay, so think about the kind of words that we use for chance and whether something's likely or not. Okay, so if we think about something that is completely impossible, then there's no way it can happen at all. It's guaranteed it cannot happen. And this goes at the left-hand end of our likelihood line. So we've got impossible there. Right at the other end of the line, here, then we've got guaranteed. It's absolutely certain, okay? There is no way that this cannot happen. So we're going to put certain there, okay? And everything else is somewhere in between impossible and certain, okay? It can't be here because this is already impossible. You can't be more impossible. Okay, and here you can't be more than certain. So our line, our likelihood line, goes from impossible right up to certain. And in the middle here, this is the place on the line where something's as likely to happen as it is not to happen, and we call that evens. Okay? So what we're going to do is look at our likelihood line, and we're going to place these events on our line, okay? So the first one here is a ball falls upwards when you drop it, okay? Now, how likely is that to happen? Well, we have to sort of think that, we are on Earth, because we are, and the chances of a ball falling upwards when you drop it, well, it's not going to happen, is it? Okay, we've got gravity, which makes things fall downwards when we drop them. Okay, so we're going to say that it would be impossible for a ball to fall upwards when you drop it. Okay, let's look at the next one. Oops, let's keep it where we can see everything. There we go. Right, so the next event here is that the sky will be dark before tomorrow morning. Okay, now again, think about where we live, think about what happens in the day and the night. So before tomorrow morning, the sky is going to go dark, because before tomorrow morning, we've got tonight. So we're going to put the sky will be dark before tomorrow morning as certain, because the sky is going to go dark before tomorrow morning. Okay, let's pick the next one. We're going to look at a flipped coin lands on heads. Now, how many different things can happen when you flip a coin? Well, it's either going to be heads or tails, isn't it? That's why you do it. Okay, so is it as likely that you'll get a head as it is you'll get a tail? Well, it is, isn't it? Because you've only got two sides. So that goes right in the middle at evens. Okay, so a flipped coin lands on heads, that's as likely to happen as it is not to happen. So it's halfway in between impossible and certain. Okay, now let's look at the next one. So it'll rain in the next 3 weeks. Well, is that impossible? Certainly not. Is it certain? I don't think it's absolutely certain, unless it's raining now. So I would say that it's quite likely, so there's probably a higher chance than evens. So I would say the probability or the likelihood that it'll rain in the next 3 weeks goes round about here somewhere. It's very likely, isn't it? But it's not certain. Now, the next one. Where will we put the event that Mrs. Finley will forget something? Now, if you know me, you will know that we are going to be nowhere near this end of the line. Okay, we're going to be right up here. In fact, we're probably going to have to overlap this one a little bit. And I'm going to put that one just below certain, because there is a very, very high chance that I will forget something. Okay. And what about this one here? Mr. McKinnon will dye his hair purple. Well, it's not impossible, is it? But it's probably quite unlikely. So, again, where will this go? Let's see. Like I say, it's not impossible. Not quite impossible, but it's quite unlikely, isn't it? So, let's put it round about there. Okay? So, we can see that we can use our likelihood line for placing events if we know how likely they are. Okay, so there's nothing precise about what we've done here. There's no numbers involved. All we're doing is saying whether it's impossible or certain or somewhere in between. And for the somewhere in betweens, are we near the middle or are we near the ends? Okay, so what we can do now is put numbers onto our likelihood line. Okay, so making this a little bit more mathematical now. If something is impossible, we say the probability of it happening is 0. Okay, there is 0 chance of it happening. So that's impossible. And certain, we use the number 1. Okay, so if something has a probability of 1, it means it will definitely happen. It's absolutely certain. It's guaranteed. Okay, what would you think evens has a probability of? What would be the number that goes with evens? If something's as likely to happen as it is not to happen, then it's going to be halfway in between 0 and 1. So halfway in between 0 and 1 is a half, or 0.5 if we're using decimals. Either is fine. Okay? Now, there is a way to calculate probability. So this is really important now. If we're going to calculate a probability, this is how we do it here. It's a fraction. Okay? So it's the number of favourable outcomes over the total number of possible outcomes. Now, putting that in plainer terms, then the top of the fraction, well, let's look at the bottom first. The bottom of the fraction is the total number of different things that could happen. Okay? On the top of the fraction, you've got the things that you're interested in the question. So, for example, if we look at these counters that we've got here, we've got 7 red counters, count them. So we've got 1, 2, 3, 4, 5, 6, 7. And we've got 3 green counters, 1, 2, 3. Okay, so if these counters were all in a bag where you couldn't see them, if we pick a counter at random, what's the probability that it will be A, red? Well, the way that we write probability is we write P and then in brackets the thing that we're interested in. Okay, so the probability that it's red, actually I'm going to do this underneath, it's a bit better for space. So probability that the counter picked at random when we can't see them is red is, we're going to have to look at this fraction here up at the top. So on the bottom of our fraction goes the total number of possible outcomes. Right, so basically the bottom of the fraction is how many different things can happen here? How many different counters are in that bag? Well, there are 10 counters in the bag altogether because there's 7 red ones and 3 green ones. And the number of favourable outcomes is the one in the question. So that's the red counters. So we can see we've got 7 red counters. So 7 is what goes on the top of the fraction. Okay, so the probability of picking a red counter out, if you pick one at random, is 7/10 because there are 7 red ones and 10 counters altogether. Okay, so part B, excuse me, what's the probability that a counter picked at random is green? So we write down capital P, green in brackets, And we do it in the same way. How many different things can happen? That has to go on the bottom of the fraction because that's the total number of possible outcomes. So there are 10 different counters. Okay, how many of them are green? That's the number of favourable outcomes because that's what the question's about. So that's 3. So the probability of picking out a green counter is 3/10. Part C, probability that our counter picked at random is white. Okay, well, still there are 10 favourable outcomes, 10 different things when we pick a counter out of that bag. How many of those counters are white? Well, none of them are white, are they? So none out of 10 is just the same as 0 altogether, because the probability of picking a white counter out when you've only got red ones and green ones, it's 0, isn't it? It's impossible, it can't happen. And then the last one, the probability that the counter will be round. Well, look at them, they're all round, aren't they? So we've got 10 different counters altogether. So number of favourable outcomes, that's the number of counters that are round. Well, that's all of them, it's all 10. So we've got 10 out of 10, and that makes a whole one altogether if we've got 10 tenths. Okay, so the probability that the counter is red is 7/10. We could write that as a decimal, 0.7 if we wanted to. Probability that the counter is green is 3/10, 3 out of 10. We could write that as 0.3. The probability the counter is white is 0 because it's impossible. And the probability that the counter is round is 1 because it's absolutely certain. Okay, so there are questions for you to try just now, and they're all similar to this. So just remember, when you're making your fraction, to say what the probability is, on the bottom of the fraction goes the total number of different things that can happen when you do the thing in the question. So pick out a counter at random, for example, or pick a chocolate at random, or pick a pupil out of a class. So on the bottom goes the total number of different things that can happen, and on the top goes the ones that are in the question. Okay, so for example, So for example, when it was red counters, then on the top it goes red. When it was green counters, the number of green. Okay, so I've got questions for you to have a go at just now. Just shout if you're stuck with anything, and I'll see you soon.